Welcome back, science fans. Today, we're diving into a topic that's confusing to most people, quantum physics. Now, before you run away, let me assure you it's not as weird as you think. It's actually weirder, but also incredibly useful. Technologies like communication networks, advanced computer algorithms, and even temperature sensors all rely on quantum physics. While we could talk for days about how our reality is shaped by this world, let's start with one of the most mind-bending: quantum superposition. Let me simplify it for you. In the world of tiny particles, things can actually be in two places at the same time. They can even move through barriers and share a connection, no matter how far apart they are. This may sound like science fiction, but it's not. Consider the famous double-slit experiment, where a stream of electrons are fired at a barrier with two slits. Classical physics would predict the electrons would pass through one slit or the other. However, in the quantum world, the electron behaves like a wave and passes through both slits at the same time, creating an interference pattern on the other side. Yes, you heard that right. The electron goes through both slits at the same time. That's quantum superposition. But when you consider particles as waves, these quantum quirks begin to make a lot more sense. If you think about it, waves can easily be in two places at once, like when they split at a fork in a river. Now that we've talked about the wave-like nature of particles, let's consider what happens when we try to measure them. And this brings us to another cornerstone of quantum mechanics, the Heisenberg Uncertainty Principle. The idea here is that the more precisely you try to measure one property of a particle, like its position, the less accurately you can know another related property, like its momentum. It's like having a pair of binoculars that can either give you a very close-up view, allowing you to see an object's position, or a wide view where you can see its motion, but not both at the same time. You might wonder, if particles are so slippery and elusive, how do they interact with each other? This leads us to an even stranger phenomenon: quantum entanglement. Imagine you have a pair of magical dice. You and a friend each roll your dice, and no matter how far apart you are, even if one of you is on the moon, the outcome of your rolls will always be linked. If you roll a 6, your friend will also roll a 6. Even Einstein was puzzled by this, referring to it as spooky action at a distance. Just like the magical dice that can have multiple outcomes until they're rolled, quantum particles are in a similar state of limbo until measured. Why are these entangled particles behaving like this? There are a couple of theories that try to explain it. The Copenhagen interpretation suggests that quantum particles don't have definite states until they're measured, and measuring one entangled particle determines the state of its partner. To make this easier to grasp, consider the famous thought experiment known as Schrödinger's cat. Imagine a cat in a sealed box. According to quantum mechanics, the cat is both alive and dead at the same time until you open the box to check. The act of looking causes the cat to be either definitively alive or definitively dead. Just like the cat, entangled particles are in multiple states at once, and it's only when we observe one that both particles become that state. And even more strangely, when you measure a particle, it suddenly appears in a single location, defying its wave-like nature. This is another aspect that even scientists don't fully understand yet. Imagine a sound wave spreading across a crowd, but the moment one person hears it, the sound wave concentrates itself in that single person's ear, and no one else hears a thing. It doesn't make sense according to our everyday experiences, right? But that's exactly what happens in the quantum world, and it's these strange behaviors that are the underpinnings of modern technology. So, you might be asking, why should I care? I'm not a quantum physicist. Well, the quantum world isn't just a playground for scientists. It's the foundation of our reality. It's why the sun shines, why your coffee stays hot, and why your computer works. New technologies are on the horizon that could revolutionize medicine, energy, and even our understanding of the cosmos. Have you ever watched a science fiction movie where people can beam from one place to another? Well, that's not entirely fantasy. Researchers are already experimenting with quantum teleportation. No, it's not as flashy as beaming someone from Earth to a spaceship, but we have already teleported information from one particle to another. It's baby steps, but who knows where we'll be a few decades from now? Teleportation might still be science fiction, but quantum mechanics is inching us closer to making it a scientific fact. The quantum realm is not just a subject for textbooks, it's the strange, fascinating foundation upon which our world is built. It's the reason why science fiction doesn't seem so fictional anymore. So the next time someone brings up quantum physics, you won't just nod and smile. You'll know that this bizarre and counterintuitive field is shaping our lives in ways we can't even imagine yet. If you found this video informative, please give it a thumbs up and subscribe for more content like this. Thanks for watching. Until the next time.